Hello everybody and welcome to the stream. Today we're going to be continuing on what we did in the last short video where we added some more input capability to give more control to the user. And today we're actually going to be organizing all of our input methods, including joysticks, into our program. So let me just actually... Alright, so let me just load up the music. I'm going to be listening to a classic Modern Warfare 2 soundtrack. Alright, so let's... alright, so we'll go desktop. Alright. Alright, so let's go ahead and just see what we did in the last video. So right now we have this picture of Obama and an American flag, and we just bound the up and down keys to change the mixture value. So if we press up, you'll see more of the second image, and if you press down, you'll see more of Obama, which you might want, you might not want. I'm not going to say anything about it. Alright, so the first thing we're going to do is we're going to learn how to we're first going to integrate some keyboard input. So I need to put this down. It's too powerful. Okay. So we're going to go ahead and organize all of our input methods into classes. So in source, I'm going to go ahead and create a new folder. It's called IO. And then in there, we're going to start off with the keyboard. So I can go ahead and create a class for keyboard with keyboard.h and keyboard.c. So in the header file, we're going to say if not defined. This is just a classic header. So if not defined, keyboard h define keyboard h. Then go to the bottom and say endif and define, or endif. And then we need to include our glfw header, so include glfw/glfw3.h. And then now we're going to start constructing the class. So class keyboard, and we're just going to have three things to run. So we're going to have two public static methods and then one private static variable. So in the public, so if you guys remember, first or second video in this series, one of the first lines of code that we actually wrote was this glfw set frame buffer size callback. So this method gave OpenGL a callback, so a function to call whenever the frame was resized. So we're going to do something similar with the mouse and keyboard, where whenever a key is pressed or whenever the mouse is clicked or the mouse is moved, we're gonna create a callback for that. So in keyboard.h, we're gonna have a static method, so static void, and we're gonna say key callback, and then it's gonna take 5 parameters. So glfw window pointer window, int key for the key code, int scan code, doesn't really matter, int action, this will determine if it's press or release, and then int mods, I'm not entirely sure what that is. Alright, and then next we're going to want to create a method that will allow us to retrieve the state of a key. So it's going to be is static bool, because we're going to return true or false if it's up or down, key, and we're just going to pass in the key code for it. And then the private will just be a Boolean array, so static bool keys, just like that. Alright, now in keyboard.cpp, we're going to go ahead and include the header, like that, and let's go ahead and, so because our variables are static, we have to define them in a source file. So the way we're going to do this is bool keyboard : keys, and then it's going to be the size of, glfw has a number for this, so it's glfw_key_last. So that's a macro that just says how many keys there are, and we're just going to initialize all of them to 0 or false. Next, let's create our methods. They're going to be really simple. So let's go ahead and say void keyboard colon key callback. So we're going to create our callback now, and you can actually just copy and paste the parameters if you don't want to type them out again. And all we're going to say in here is keys at key is equal to action does not equal glfw release. So if the action is not glfw release, that means that it's press. That means that the action is glfw press. I'm not sure there's a macro for it. I don't think there's a macro for it. No, let's actually just do action is equal to glfw press. Because I believe that's what we have in main. Let's check that. Yes. Okay. So if the action is glfw press, say true, otherwise say false. And then next we just want to create that method to retrieve the state. So boolean keyboard keys, and it's just going to be a parameter for the key code, and it's just going to return keys at key. Just like that. This method should be key, not keys. Alright, so let's go ahead and test this really quickly. So go back into your main folder, and we have to create that callback, or set that callback first. So the way we're going to do this is, we have to include our header first. So at the top, under shader, go ahead and say include io/keyboard.h, because that's a local file. And then next, under the set frame buffer size callback, skip a line and then say glfw set key callback, and we're going to say window and then the function. So it's going to be keyboard key callback, and we can do this because it's a static method, so that's how we can access that. So let's go ahead and use this now. So let's go down into our process input method. We currently have these methods right over here that have glfw get key. So let's go ahead and replace them with our new method. So in the first if statement, so let's just do the escape. So if keyboard key at let's say glfw key escape. If that function returns true, then we set the window to close. So let's go ahead and test this out. So I press escape and it works. All right. So now let's replace the other ones as the up and down ones as well. So we're going to say keyboard for the top one. We'll say keyboard key, and this time we'll pass the glfw key up. And then for the second if statement, we're going to say glfw key down. Keyboard key glfw key down. Make sure you have all your arrows. Alright, so let's go ahead and make sure this all works. So when I press up, yep. Alright, nice. Okay, so that was keyboard. That was pretty simple. Now let's do mouse. So the mouse class is going to be somewhat similar, but this time we're going to have 2 callbacks because, well, we could have 3 for the scrolling wheel, but we're not going to worry about that right now. We are just going to have a callback for the position of the mouse and then the button of the mouse. So let's go ahead and create a new header and source file for it. So I'm just going to call it mouse. And mouse.cpp. Alright. In mouse.h, we're going to go ahead and say if not defined, mouse h, define mouse h, and if. And we're going to include our glfw headers again. And then we're going to have a class mouse. This time we're going to have 5 public methods and 3 private members, 3 private variables. So for public, we're going to have static, void, mouse, pose, callback, or we can call this cursor position callback. And we're going to pass in the window, and just add X and Y, so double X, double Y, just like that. And then the button callback, so static void, mouse, button callback, GLFW, window, star, window, int button, int action, and this is going to be the same thing as the keyboard, so it's going to be, last one will be int mods. Next method, next we're going to have the 3 data retrieval methods. So we're going to have X, Y, and then button. So we're going to say static, double, get, mouse, X, no parameters, static, double, get, mouse, Y, no parameters, and then static, bool, button. This is going to be the same thing as the keyboard one. We're just going to pass in int button. And then private. We're going to store these variables in static, double, X, static, double, Y, and then another Boolean array, so static, bool, buttons. Alright, now in mouse.cpp, let's go ahead and include that header, so include mouse.h. And then we have to define our variables. So we're going to say double mouse ::x is equal to 0, double mouse ::y is equal to 0, and then our Boolean array, so bool mouse ::button, and then we're going to say glfw mouse button last, because you might just think, oh, there are 3 buttons on a mouse, the right, left, and the cursor, but there are often in more gaming mouses, there's, you might have some other buttons on the side that you can map to things, stuff like that. Alright, and we're just going to initialize all of them to 0 right now. Make sure that's a plural button. Okay, let's do the position callback right now. So, void mouse, mouse position callback, glfw window, star window, double X and double Y. Oh, it's cursor position. That's right. Is that it? Cursor pose. Okay. I did forget to do one thing. In the parameters of the button method, just make that int have an underscore in front of it, just so it doesn't the compiler doesn't confuse it with the method. Alright, so it's cursor pose callback. Alright, so the way we're gonna have to do this is we're gonna want to normalize these coordinates, because the way we display shapes is we normalize them. So to do that, we're gonna have to get the width and the height of the window. So we're gonna say int width, height, and then we're gonna say glfw get frame buffer size. We're gonna pass in the window, and then a reference to width, and then a reference to height. Alright, and then we're gonna want to normalize coordinates. Alright, so the way to normalize the x coordinate is we're gonna subtract, we are going to, how do I want to do this? me just think. Hold on, let me just think about this real quick because I have a formula over here. 2 times x minus width. Alright, so the way we're going to get the x variable is we're going to say, we're going to do 2 times the cursor position because this returns it in pixels and we want it in normalized. So we're going to say 2 times x divided by width, and then we're going to subtract 1 from it. And then for y, we're going to do the opposite actually. We're going to do 1 minus 2 times y divided by width, 2 times the parameter y divided by the width, because the reason why we're doing it the other way around is because this cursor callback will return it so that the lower left, or the origin is in the top left and positive y goes down, but we want it the other way around, so we're going to want to negate that. You'll see something similar with the joystick as well. Okay, now let's create the button callback. So it's going to be actually pretty similar to the keyboard one. So we're going to say void mouse mouse button callback. We're going to pass in the window. And then we're going to int button, int action, and then int mods. And then all we're going to say is buttons at button is equal to, and then once again action is equal to glfw press. Alright, and then next is just the 3 retrieval methods. These are all one line, so double mouse get mouse x, return x, double mouse get mouse y, return y, and then the last one is boolean mouse button, and we're going to pass in the button parameter as an integer, and then all we're going to say is return buttons at the parameter button. Okay, so yeah, that's the mouse, and let's go ahead and just make sure that this all works. Let's go ahead and bind it, or actually, let's just print out the codes of each of the buttons that we're pressing. So, let's go ahead and say for int I is in the, so I'm back in main.cpp in the process input method. So for int I is equal to 0, I is less than glfw mouse button last I++. We're gonna say if, or we actually have to include it and set the callbacks. I forgot to do that. So at the top of main.cpp, under the keyboard include, just go ahead and say include io/mouse.h. And then we want to set the 2 callbacks this time. So under the second key callback, we're going to say glfw set cursor position callback. You can see that there are a lot of callbacks in there, and I'll go through a couple of them after this. So we're just going to pass in window, and then the static method of mouse cursor position callback. And then for the button callback, we're going to say glfw set mouse button callback, and then we're going to say window mouse mouse button callback, just like that. Alright, so now that we have set the callbacks, glfw will call these methods once the cursor moves or once the user clicks the mouse. Alright, so now let's go all the way down again to the process input method, and we're going to say in the for loop, we're just going to check to see if any button is pressed. So we're going to say if mouse button at I. So if that returns true, we're going to say the print out I, and then just end line. So we can just use this to just go ahead and see what the buttons have as an idea. let's go ahead and run this. And in order for this to work, you have to have the OpenGL window focused. So I'm going to click the left button, and that's 0. The cursor is 2. So if I press down on the cursor, it's 2. The right button is 1. I have 2 buttons on the side of my mouse. That's going to be 4 and 3. And then the DPI button, it's not a thing. So I guess it doesn't register. Yeah, so let's see how many buttons there are actually. So GLFW mouse button. So there's up to 8 buttons. That's pretty cool. And then it has names on it. That's pretty cool. So last, left, middle, right. Alright, so let's go ahead and bind this to something. So let's say so let's go ahead and have it so that so that if you hold the left button down, you will be able to drag the shape with it. So we're gonna say Alright, so in the process input method, how do I do this? So we're gonna have to use some matrix transform once again. Okay. So go down into. Alright, so let's go ahead and create a global variable. A global matrix variable. So let's go ahead and say GLM mat4. Let's say mouse transform is equal to GLM mat4 1.0f. Just to initialize it at 1.0f. So make sure that's right. And then we're going to say in the process input method, we're going to say, you can get rid of the printing one. So we're going to say if mouse button, and we're going to say glfw mouse button left. So if the user is holding the left button down, we're going to say we're going to get the position essentially. So we're going to say int or double x is equal to mouse get mouse x, double y mouse get mouse y, and then we're going to go ahead and reset the matrix and add the transformation. So mat4 or mouse transform is equal to GLM mat4 1.0f. And then mouse transform, we're going to use another GLM method here. So GLM translate, we're going to start with the original one, so mouse transform. And I just want to just make sure I'm doing this all right. Rotate scale, translate GLM method. So we're going to just go ahead and say GLM vector2, or it's passing a 3D vector. So we're going to say, alright, so let's say we'll pass an x, y, and 0.0f. And that should be good there. And then let's go ahead and actually set it. Let's actually apply this effect, because if we do it now, nothing will happen. So in the while method, let's go ahead and say shader.set mat4, and then we're going to say mouse transform, and we're going to pass in mouse transform matrix. Alright, and now we have to actually add this to our, I'm using the yeah, so in our vertex shader, we're going to go ahead and say, we're going to have a uniform variable because we're setting it in code. So uniform map for mouse transform. And then GL position will now equal mouse transform times that thing. Alright, so let's go ahead and run this, hope we don't get any errors. Oh, it works, nice. So you see that, I may have normalized these coordinates incorrectly. So yeah, it moves with the mouse, that was all I meant. You actually just go ahead and make sure I normalize the coordinates properly. So in the method, input method, I'm just going to go ahead and print out cd cout. I'm only going to print them out if the button is down. So std cout mouse get mouse, or actually I can just print out x and y right here. std cout x space y. And then end line. Alright, so that looks right. Except the y is not multiplied by, I need to multiply the y by 2, I guess. Yeah, that makes sense. I just need, alright. So in mouse.cpp, what? That doesn't make any sense though. Or maybe, here, let me, don't type anything yet. I'm just gonna test something. See if this works. Nope. Alright. For some reason I had to multiply everything by 2, but there's no like standardized formula for this. But that's the best I can get right now. Okay. Nice. Alright, yeah, so that's the mouse. Now let's move on to the last thing, which will be the joystick. Alright, so I'll let you guys get all this code down. And next I'm going to go ahead and connect my joystick right now. How long have we been up for? It's been half an hour, okay. This is not going to be that long of a stream. Yeah, that's all. Anyway, hope you guys are having a nice Monday morning. I currently don't have class at this time, so that's why I'm able to do this. But I do have class in the afternoon, so I can't just be streaming for 18 hours. But if I could, anyways. Alright, let's go ahead and let's start with the joystick stuff. Alright, so in IO we're going to create another thing, or another set of files. So we're going to say joystick.h and joystick.cpp. So if you were wondering what this pragma once means, that's just a Windows thing to replace the if not defined define. This just means define it only once, but this doesn't work on Mac. So that's why I replaced it. Because OpenGL does work on Mac. I think I mentioned this in the first video, but OpenGL is cross-platform. Alright. So we're going to go ahead and just delete that and say if not defined. Joystick H. Define joystick H and then end if. Alright, so we need our includes again, so include glfw slash glfw3.h, and then we're going to have a bunch of macros, but we will determine those later on. Alright, so we're going to go ahead and say class joystick. There's no callback for this one because it's not technically because OpenGL doesn't automatically listen for it. There's no there's no defined callback for a joystick, so we're gonna have to create our own callback essentially and call that every time the while loop is rendered. So we're gonna have it's gonna be a class because you can have multiple joysticks, and all these are they're not gonna be static members. Well, only one of them will be static, but the reason why is because you can have multiple joysticks connected, whereas with the mouse and keyboard you can only have one unless you went crazy and had 5 keyboards and played Siege with 5 keyboards on a team by yourself, but that's another story. Alright, so joystick. Int I for the ID. And then we're going to have our void method for update, and this will be called every render. Make sure that this is all public right here. Next, we're going to get float trigger state for each trigger, and then we'll say int trigger, and then we're going to have an unsigned char button state. So unsigned char button state int button, and then bool is present. We're going to map all these are essentially just data retrieval methods. We're going to map all of them to variables down below. Alright, and then the one static method is just going to be get ID. So static int get ID, and then we're going to pass it in. And then our private methods will be int present. We're going to have int ID, const, star name. We're going to have an axes count. And then we're going to have a float array to store those axes values. So I believe there are going to be 6 for them. So there's going to be X and Y on the it's going to be X and Y on the for the actual sticks themselves, and then the triggers. So we can actually rename this trigger state to axis state, and then into axis. Alright, and then semicolon, and then into button count, and then const unsigned star button. Alright. So, like I said, we're gonna have a bunch of macros. We're gonna go ahead and actually discover what those macros are. So let's go ahead and define these methods real quick. First, this is not gonna be too much. So in the joystick.cpp, we're gonna include the header, include joystick.h, and then we're gonna have the constructors, just joystick, and then int I. And all we're going to say is ID is equal to get ID at I. And then we're just going to update it. And next we're going to write the update method. So void update, or void joystick update. And we're going to say present is equal to glftw joystick present. Oh, wait a minute. Set joystick callback. Oh, this is only called when the joystick is connected or disconnected. There's no actual. Well, maybe. No, there's no callback for the buttons. That would have been cool if there was. But all right, so get joystick or glftw joystick present, and then we're going to pass in the ID. And then if present, we're going to set the other three. So we're going to say name is equal to glftw get joystick name. Pass the ID. We're going to get all the axes, so glftw get joystick axes, and we're going to pass in the ID and the axes count, a reference to the axes count. So this will store how many axes there are, and then buttons is equal to glftw get joystick buttons. And then we're going to have an ID and then a reference to button count as well. Let's go ahead and actually create 2 more methods up top just to get the number of axes and buttons. Just because we might need that. So int get axes count. And then int get button count. Alright, so update. We did that. That just gets all the information of the current information. This doesn't automatically update, which is why we'll have to call this every rendering of the loop. Alright, next let's get the axes state going. So float joystick axes state. We're going to say int axis. We're going to say if present, return axes at axis. Otherwise, just return negative. Next, we want to do the button state, so unsigned char joystick button state. Button state. And then int button. Then we're going to say if present. Return buttons at button, and otherwise return glftw release. Alright, next we want to have the get axes count, get button count, which should be relatively simple. Int joystick get axes count, return axes count, and then int joystick get button count, return button count. Alright, next one is just boolean joystick is present, and that just return present. Alright, this will be the most tedious method that we write all day, because we're gonna have to get the ID methods. So for this method, let's write the definition. So it returns an integer and just joystick get ID. It's a static method, and int I. And essentially, we're going to have a switch for I, and there can be up to 15 joysticks connected at once. So, yeah, this is going to be cunning for no one to write out. We'll actually just do the one for now, and then I'll add the other ones post-stream, and you can just copy them, but you don't need to write them. Alright, so it's just going to be case 0, and we're just going to return glftw joystick 1. And then default is just return it. You can map 1. You can make it 1 to 15, but I'm just going to do 0 to 14. Okay. So now let's go ahead and now we have all our methods. Now let's go ahead and back into our main.cpp. Let's go ahead. Let's include it. So we're going to say include io/joystick.h. Next, we are going to going back into our process input method. So we have our mouse, and then finally we're going to have our joystick. So like I said, we have to update our joystick, or actually, one thing I did forget to do is create our joystick variable. So let's go ahead and we're going to create a global variable. We're going to say joystick J1. And we're just going to pass in the ID of 0 there. And then before our render, let's go. Oh no, my dog. Not even. 1 second. Good on my arm. Now I can't type. Alright, so we're gonna go one-handed. This is not gonna be good. I can't even use my mouse. It's like almost impossible. I'm gonna raise my chair a bit. Alright, never mind, we're all good. Alright. So before our while loop, let's just go ahead and print out if it's connected. So we're gonna say if J1 dot is present. We're going to go ahead and say stdcout. Oh, we should actually have a get name method that we never added. So let's just go ahead and add that. So const char star get name in joystick.h, and then just all that's going to be is just say const char star joystick get name. Did I forget a semicolon? I did. I put a colon. Alright. So let's go ahead and say if J1 dot is present, we're going to print out J1 dot get name is Alright, so now that let's actually just test this out, just to make sure it's registered by remote. So I'm going to go ahead and just connect it by USB. And the good thing is, if you have a DualShock controller, you don't need an input mapper. You will need an input mapper if it was DirectX, but for OpenGL you don't, which is pretty nice. So let's go ahead and run it. And we got an error. Joystick J1 what? J1 redefinition? Previous definition was function. Oh no, this is the sad one. Oh, this is the soundtrack. I cannot believe that they got Hans Zimmer to do this. It's so good. This shit is just so good. Yeah, 231 is. Yeah. Alright, why is this? Let me just try running it again. No, same error. What happened? No, it's... This is really weird. Redefinition. Let me just go ahead and restart Visual Studio, see if that works out. Maybe it probably won't, but maybe it won't. No. I mean, I can try getting another main J. Let's try that. And then just replace the name. Gonna add don't worry about anything I just listen to the music. That's all it is. Alright. Oh. Alright, so it is not present, which is no good. Maybe I have to update it. Main trade on update. Ah, there we go. Alright, so wireless controller is present, and that is the name that Windows gave my controller, which is Swift. If we got one into the devices, we would see that as well. Alright, so we see that it's present, and now let's go into our process input, and we have to, once again, call this method every time that the loop breaks. So we're going to say mainj.update, just like that. And then let's go ahead and let's take away control of the image to our mouse. So let's just comment this out for now. And then we're gonna say, or actually we have to, no, we can keep that for now because we have to determine what IDs are what. So we're gonna start with the buttons first. So for int I is equal to 0, I is less than mainj.get button count, I++. And then we're going to say if mainj.button state of I, we're going to say standard print out I. So when we press the button with a certain ID, it should show up, it should give us the ID. So I'm just going to go ahead and go through. I have a DualShock and it has 18 buttons. So let's go ahead. Make sure you open. Oh, you know why? I think it's just the normalize isn't truly working. That's probably fixed later. Alright, so I'm going to go ahead and start with square. So square is 0. X is 1. Circle is 2. Triangle is 3. 4 will be the left shoulder. 5 will be the right shoulder. 6 will be the left trigger, 7 will be the right trigger. You can see them logging right here. 8 will be the select button, so it's the left, like it's going to be like the left button on the middle. So on DualShock it's share. And then the start button, which on the DualShock will be options, on Xbox it will be menu. And then So start is 9, then left stick, if you press it in, is 10, right stick is 11, home is 12, so it's the PS or Xbox button. 13 will be the touchpad, DualShock. I don't think Xbox has the color for that. D-pad up, D-pad right, down, and left. So let's go ahead with this knowledge now. I'm actually just not going to, or I don't want to type all this down, but I will. Alright, so go back to your joystick 8, and we're going to create 18 macros for now. So it's going to be analog. So we're just going to define GLFW, joystick, BTN left to 0. I'm not going to type all these down. I'm just going to go, because I have this code somewhere, so I'm just going to go to my repository and find it. I should probably put this in case. But it'll be on GitHub right after this. If you don't know where I am, I'm just on GitHub in my program. And it's the same project structure. The reason why I put button left, down, right, up here is just biased towards Xbox or PlayStation. Let's go ahead and just display this as yes. Alright, so those are the 18 analog inputs, and now we're going to get the axes. So we're going to do the same thing in the main method collection. Instead of doing get button count, we're going to say get axes count, and then we're going to say main j.axes state. And then we're actually just going to print out axes, standard cout main j.axes. We don't want to print it out every time, so I'll just say if main j.button state. I'll just say if I'm holding down the X button. So that's going to be button down. So it's going to be GLFW, joystick, BTN down. Not BTS. And just one thing I forgot is just axis state has a parameter of not that. Alright, so let's go ahead and test this out. So if I hold, so let me just make sure you guys can see this. So if I hold X, you see that we get all these values. So they look really annoying, but that's just the default values. So I'm going to move the left stick down, and what we should get is a positive Y somewhere. What we are getting is I can't really decide. There should be only 6. So left stick Y is going to be this 0.99 right here. So that's going to be the second value. Because the 6 from the so it's the last 6, and we're just looking at the second one because that's the thing that's been changing. So then let's try left stick X. So if I hold X, alright, so hold X, and it looks like the first value is left stick X, because that's a -1 there, that's been changing. Next, let's do the right stick. So hold X, right stick, and that's the third value. And then right stick Y. That's weird. Right stick Y is going to be the last value. and then left trigger will be the third value, or the fourth value, and then right trigger will be the fifth value. Yeah. So you're probably wondering, oh, why are some of these values like this? Well, this is the purpose of dead zones, essentially, because there's no perfect zero, especially on the sticks. Like, you see that there's no perfect value on the sticks. So usually you'll have usually games will incorporate a dead zone that's like 0.1 or 0.05, something like that. So every time that the value goes above 0.5, the game will interpret that as an intentional. So let's go ahead and define these macros real quick. So go back to joystick H, and we're going to say, in the axes, we're going to say, define GLFW, joystick, axes, left stick, X and 0, and I'm just going to copy and paste it from my file over here. It's essentially what we just found. That's all that is. So now if we replace it with like left stick X, we can do that. So now that we have everything mapped to a macro, let's go ahead and actually give control of the image to the joypad. So I'm going to comment out the mouse control. Now let's go ahead and say, let's give it to the left stick. So we're going to have to incorporate a dead zone again. So let's go ahead and say this. So let's say float LX is equal to main.j.axes state, and we're going to pass in the macro GLFW joystick axes left stick Y, or left stick X. Just like that. And then float ly is equal to main.j.axes state GLFW joystick axes left stick Y. So let's have it. So let's say dead zone of 0.05, like I said. So account for dead zone. So if standard absolute value of LX is greater than 0.05 because it can be negative. And the one thing we are going to do is we're going to have to negate the LX. Just because down on the stick is positive, up is negative. Weird, but alright, so if the value is greater than 0.05, then it's a valid thing. So we're going to say mouse transform is equal to, we're not going to reset this time, GLM translate mouse transform, and then we're going to say GLM vector 3, and we're only doing the X direction, so we're going to say LX, and let's just divide it by 10, so it's not too much. We're at 0.0, and then 0.0. Alright, and then we're going to do it for Y as well, so if standard absolute value of LY is greater than 0.05. We're going to say mouse transform is equal to GLM translate. We're going to say mouse transform GLM vector 3 0.0 in the X direction, LY divided by 10 in the Y direction, and then 0.0 at the Z direction. Okay. So let's go ahead and run this. Hopefully, so, like we saw before when we were determining the axes, we saw that there was a negative 0.02, but we're not trying to program to account for that because that's just values that it will automatically count. You can't produce a perfect. So if we press up, get up. Nice. I can push it all the way over and it doesn't matter. But this is actually pretty nice. And nothing else does anything. Alright. That has been more advanced I/O. So yeah, that's all I have. That's all the code that I have for you guys today. I'll leave it on this for now. But I'm just going to give you guys a little bit of what I plan to do in the future. So, right now, I have been going through... I've been using a site called Learn OpenGL, and I showed this in the second video. I've showed this in a couple of videos. And I've just been using that to guide my tutorials. I want to be able to go through the first unit of that. So let me actually just... Learn OpenGL. So I want to just go through the getting started units, and then after that I want to be able to go on my own, in my own direction. So after getting started, so we still have coordinate systems to do and camera. Might be able to combine those and do a single video, but I'm not sure. Let me just, am I connected? I am. Hold on, let me make sure I'm just connected everywhere. Excellent connection. Hopefully this doesn't go down. Connect, please. Okay, I'm good. Alright, so hopefully you guys you can see this. So I want to be able to go through this first unit. So we still have coordinate systems, and then the camera, which we might be able to do in one video, because it's should be relatively the same thing. And with the camera, we'll actually be getting into walking around, so... doing... Alright, this isn't loading for some reason. Whatever. And then after that, I'm going to be sprinkling in some stuff from these other units, but mainly I'll be trying to go in my own direction. See what else I can do. But yeah, that's all I have to say about that. Yeah. That's pretty much it. Do I have anything else to say? Let me just show you guys Obama and how fast Obama can move. Damn, he can zoom. Oh my god, he's so fast. So fast. Holy shit, you couldn't even see him go. Watch this. Holy shit, that's fast. Oh my god. Alright, yeah, that's all I have for you guys today. Hope you enjoyed the stream. Let me just find my dog. There he is. There he is. There's my boy. And as you can see, we can do both at the same time. Yeah, alright, that's all I have for you guys today. And I will see you guys maybe later this week, depends on if I have time. Hopefully later this week. Alright, I'll see you then. Bye.